And Dr. Ajay, kindly go ahead and ask Dr. Saz to share his presentation.
Good morning, everyone.
Good morning.
Happy Diwali, all of you, first of all. Today's topic for the seminar is sterilization of instrument in urology. Now, I request Dr. SAHADEEP to express his views. Dr. SAHADEEP, please start.
Yes, sir. Thank you, sir. Good morning, everyone. I hope my screen is visible to everyone. Today we'll be we'll be having a presentation on sterilization of instruments in urology. First of all, some basic definitions regarding sterilization. First is cleaning, which is removal of all the visible soil that can be organic, that is blood or any tissue on the endoscopes, or inorganic material from the subject objects or the surfaces of endoscope. Second is sterilization, that involves the procedure to destroy or eliminate all types of microbial life, including the bacterial spores. Disinfection, it eliminates many or all the pathogenic organisms except for the bacterial spores on the inanimate objects. The sterilization is porocidal, whereas the disinfection removes only the bacteria, viruses, and fungi, and not the spores. Antiseptics prevent or arrest the growth of organisms by inhibiting their activity or destroying them. Antiseptics are basically applied to living tissue and skin. Disinfectants are applied to inanimate objects. Now, further classification of the disinfectants. First is chemical sterilants. These are the disinfectants that kill all spores because of their prolonged exposure time, that is from 3 to 12 hours. The second is high-level disinfectants. They are similar in concentration to chemical sterilants, but they have a shorter exposure period and they kill all microorganisms except large number of bacterial spores. Then comes intermediate level disinfectant that may be scheduled for mycobacteria, vegetative bacteria, most viruses and fungi, but not necessarily kill bacterial spores. And the last comes the low-level disinfectants, which have a practical period of exposure time that is less than 10 minutes, and it kills most vegetative bacteria and some fungi and some viruses. This is after rinsing of any endoscope and flushing the channels with the disinfectants, we have to wash the endoscope with a sterile water, filtered water, or tap water to prevent any of the remnant disinfectant on the endoscope, because if there is any remnant on the endoscope, it can lead to side effects in patients like disinfectant-induced colitis. And rinsing of endoscope is should be done with sterile water ideally to prevent contamination of the endoscopes with organisms in tap water such as non-tuberculous mycobacteria, Legionella, and gram-negative bacilli such as Pseudomonas. If sterile water is not available, then alternatively, after rinsing with the tap water, the endoscope should be rubbed with an alcohol rinse or should be forced air dry, should be done. What is US FDA definition of sterilized device? Sterilized device is that has been processed in a system that delivers the sterility assurance of 10⁻⁻⁶. That means there is 1 in a million chance of a non-sterile occurrence of an instrument. High-level disinfectants do not achieve this level of sterility. Then there is Spalding scheme of sterilized instrument. According to the use of the instruments in the body, they are being classified as critical, semi-critical, and non-critical. Semi-critical is the items which are normally used in a sterilized system or body cavity, such as in vascular system. Here the goal is absolute sterility. Then comes semi-critical instruments. These are the instruments which come in contact with intact mucous membrane or non-intact skin. Most of our endourological instruments fall into this category, and here the goal is high-level disinfectant. Then comes non-critical items which come in contact with the skin, intact skin, but not with mucous membrane, like camera. Here the goal is to achieve low-level disinfection by cleaning. Then we come to the steps in sterilization of endoscopic instruments. First step is dismantling. Separating all the components or the wells, all the ports have to be dismantled from an endoscope so that sterilization process can reach to all parts of the instrument. Then comes pre-cleaning, which includes removal of all the gross soiling. Gross soiling by blood should be removed at this point of use. If cleaning is not possible, especially in a hollow cylindrical instruments like sheaths or telescopic dilators, the instrument should be dipped in a detergent or enzymatic cleaner to prevent organic matter from drying in the instrument. This shows the pre-cleaning. Pre-cleaning is done basically with the brushes which are available with each instrument to remove the visible soil, which can be organic or inorganic. Then comes cleaning. Cleaning is basically accomplished either manually or mechanically with water and detergent. Manually, the cleaning has two components, that is fluidic and friction. Fluid flow and the manual friction by scrubbing and rubbing removes the soil from the instrument. And mechanical cleaning is not done for telescopes as it may damage the optics. After cleaning, the instruments are dried before packaging so that they by air blower or by oven if instrument is compatible for high temperature. This shows the automatic mechanical cleaner, and the other images shows the mechanical cleaning by a fluid method. This is a air dryer being attached to the cystoscopic sheath after the cleaning process to dry all the water residues inside the sheath. Then after packaging, after drying comes the packaging. After drying, instruments are wrapped in roll stalks or peel open pouches, and then they are placed in a rigid container like instrument trays or baskets. After packaging comes the loading, which is done in a perforated tray for free circulation of sterilizing steam and agent to ensure proper exposure to all instruments. Then comes sterilization, which is different as per the specification of instruments and availability of sterilization method. These are the image showing packaging. Packaging is mostly done in open peel pouches before placing them inside a sterilizer. Then comes storage. Storage means the shelf life of the sterilized instrument. That can depend upon the porosity of packaging material in which they are stored after sterilization and the storage conditions. Then comes the most important step of monitoring. This is done by a combination of mechanical, chemical, and biological indicators. We'll discuss in detail about monitoring now. Monitors can be of three types. They are mechanical indicators, which tell about the equipment control. Equipment which is available for sterilization, they indicate the efficacy of the equipment being used for sterilization. Then comes the chemical indicator. These are of two types, external and internal, and they indicate exposure control. That is the exposure of the pack to the sterilizing process. And then comes the pack control, which is placed inside, and that ensures the adequate packing of the instruments while sterilization. The last is biological indicators, which includes the load control, and this is the most important indicator. Load control means if there any living organism still present on the instrument after sterilization. Initially, the monitoring is done by mechanical process of the instrument. Then comes the chemical monitors, then biological. They all, when combined on a single sterilization process, they give a sterility assurance of 100%. Mechanical monitors, they are the used for basically for steam sterilization, and it includes daily assessment of cycle time, temperature, and these are done by recording the temperature charts and by pressure gauges, which assesses the pressure of the sterilizer. Mechanical indicators show what is happening in the chamber and whether the required conditions are being met. The cycle time and temperature conditions are being met. This is the image. Upper one is the pressure gauge of an autoclave, which indicates the required pressure is achieved or not. The left-hand image shows the temperature being achieved in the cycle, and then there is a recorder which records all the cycle time and duration. The disadvantages of mechanical indicators when used alone are that they are only monitor one location in a sterilizer. They do not monitor each pack or tray, and they do not indicate the sterility. 100% sterility is not indicated by lone usage of mechanical indicators. Then comes the chemical indicators. They are the heat or chemical sensitive inks which are placed either on the external surface or inside the pack, and they change color when they are exposed to the sterilization parameters. The chemical indicators should also be used only in conjunction with biological indicators and not alone. Chemical indicators, if placed on inside of pack, they signify the sterility penetration. They monitor one or more of the requirements which are being one or more of the requirements like time, temperature, and sterilant penetration. They can be internal or external, and they give instant results. And they indicate the proper conditions were met during the sterilization process. They are of two types, external and internal. First is external, which indicates the exposure control. They are placed on the outside of the pack, and they are the process indicators. Example, autoclave tape. These are used to distinguish between an unprocessed medical device from a processed one. If the external indicator does not change in color, the instrument pack should not be used. Then comes the pack control. They are placed inside each pack, tray or container. They validate the sterilant penetration, and they measure all the process parameters like proper exposure to the temperature, time, and duration cycle of the duration. The pack control uses are they detect the incorrect packing, whether they were instruments were packed too tightly for sterilant to penetrate, incorrect loading inside the autoclave. Then the malfunction of sterilizer can also be indicated by pack control. They are easy to retrieve and read. This is an image which shows a chemical indicator. This is of a Miser company, and they are available as self-seal stickers or as a labeling gun. They are different color changes for every process. Like for dry heat, initial color can be yellow and pink, changing to green and violet. For ETO, it can be yellow, red, changing to brown and green. Likewise, there are different for each chemical disinfectants and for plasma. Then comes the most important biological indicators of sterilant. They measure the sterilization process directly by using the most resistant organism, therefore bacterial spores, and they do not only measure the physical and chemical conditions necessary for sterilization as by mechanical and chemical monitors. So they are the ideal monitors. They measure the lethality of a given sterilization process. Spores which are used for monitoring the sterilization process are more resistant than the usual bioburden found on medical devices. Bacillus atrophius is used to monitor ethylene oxide and dry heat method of sterilization, and Bacillus stereothermophilus are used to monitor steam sterilization, hydrogen peroxide gas plasma, and liquid parasitic acid sterilizers. Then comes sterilization of individual instruments. According to the individual instruments, we'll discuss the sterilization process available for them. First is rigid endoscope instruments. It includes the cystoscope sheaths, integrated sheaths, rigid nephroscopes, semi-rigid ureteroscopes. These are all the semi-critical items according to the Spalding classification as discussed before. Here the process involves first disassembling, pre-cleaning, cleaning, and then instruments are evaluated at this point to check for any damage. Hard water should be avoided for these instruments because it may lead to deposition of crystals over instruments and may alter the efficacy of some high-level disinfectants. Rigid telescopes are extremely delicate and they need gentle handling. Previous telescopes were not autoclavable because their metal and glass items expanded and contracted unequally, leading to damage of rod lens system. They were usually sterilized by ethylene oxide sterilizer or by plasma sterilization, which are the low temperature sterilization, will be discussed in further slides. The sheets are inspected for any bends, rough edges, and all movable parts and valves are inspected. And sheets are sterilized by steam, autoclaving, ethylene oxide, and they can be disinfected with glutaraldehyde during in between the cases. Then come the single piece endoscopes like nephroscopes, ureteroscopes, and integrated cystoscopes. They are usually sterilized by ethylene oxide and plasma sterilization. They can also be autoclaved. The newer endoscopes these days can be autoclaved, but manufacturer instruction should be followed. The working element of transurethral resection and optical ureterotomes are sterilized by autoclaving and plasma sterilization. And TUR loops can also be sterilized by plasma sterilization and ETU. Then comes the flexible endoscopic instruments. They are also semi-critical according to the Spalding classification. Pre-cleaning is usually done at the site of use. Just after using in a case, after the use, we do the pre-cleaning, and external surface is wiped clean with a soft cloth immersed in a detergent solution. Then thorough working channel detergent solution is through the working channel, detergent solution is rinsed for 30 seconds, followed by water for 10 seconds and air drying for another 10 seconds. The most important step of before doing any cleaning of the flexible endoscope or an endoscope is leakage tester, in which a tester is attached to the venting connector of scope and hand pump is used to achieve the desired pressure. The entire scope is then immersed in the water and all flexible parts are deflected so that all the parts can be checked for any air bubble leakage, and water is observed for persistent air bubbles from any particular point. The working channels are cleaned with the manufacturer provided brushes. The brushes are provided with every endoscope according to their different sizes by the manufacturer. Then after that, the endoscope is rinsed, and then it is dried and packed for sterilization. And sterilization of endoscopes is done by flexible endoscopes is done by ethylene oxide or plasma sterilization. If sterilization is not possible, like then high-level disinfection can be achieved with glutaraldehyde, as all these urological instruments are semi-critical type of instruments according to Spalding classification. So they can only be disinfected by high-level disinfectants. Leak testing is basically performed to prevent the corrosion or damage of the internal and external endoscopes and by the disinfectants, and it also indirectly helps in preventing the patient injury. As mentioned by Krishna et al. In their paper article, that there were 2 cases of corrosive injury of larynx caused by exposure to glutaraldehyde retained in the endoscope. Basically, in this leak testing, we check for any internal channel damage or external damage, which can retain the disinfectant after the endoscope is rinsed, immersed in the disinfectant, and this can lead to injury in the patient after the instrument is used in any surgery. Basic steps of leak testing are removable all the port covers and function valves, pressurizing the endoscope to a recommended pressure, then placing the endoscope in a loose configuration and manipulating all movable parts, and then maintaining the pressure and inspection for minimum of 30 seconds. We have to maintain pressure and check for any air bubbles for minimum of 30 seconds. This is a mechanical tester. It is a pressure producing machine, and the other end is attached to the instrument. Then comes sterilization of a camera, basket, and cautery cables. These are basically sterilized by ethylene oxide or plasma vaporization. Cameras are non-critical items, so they can only be disinfected with glutaraldehyde. Then dilator accessories, balloon dilators, emplast dilators, and uretic accessories. They are usually the one-time use items, but in many countries they are being reused. So if they are reused, they can be sterilized by ethylene oxide or plasma sterilization. Alkane metal dilators can be autoclaved or can be sterilized by ethylene oxide. The percutaneous nephrolithotomy forceps or the ureteric forceps like biflange and triflange, or energy probes like pneumatic and ultrasonic, they can be sterilized by autoclaving or by ethylene oxide or plasma sterilization. Then comes the laser fibers. These are sterilized by ethylene oxide or plasma vaporization. High-level disinfection can also be achieved with glutaraldehyde. Then comes the different methods of sterilization. They are classified as high temperature methods and low temperature methods. First is heat sterilization or the high temperature methods. In that there is autoclaving. Autoclaving uses moist heat, which causes coagulative necrosis of the structural proteins of bacteria, denaturation of heat-sensitive enzymes in the microorganisms. The advantages of autoclaving is that it is non-toxic, easily controlled, monitored, fast, cheap, and most easily available method of sterilization. But the disadvantage is that heat-sensitive instruments like flexible instruments and older telescopes cannot be autoclaved, although the newer telescopes nowadays which can be autoclaved, and sharp instruments tend to lose sharpness due to autoclaving. For complete sterilization by autoclaving, pressure of 106 kilopascals and temperature of 121 degrees Celsius should be achieved for 30 minutes. A single cycle of autoclave consists of 15 minutes of preheat, 15 minutes of pressurized steam, and then followed by 5 to 15 minutes of cooling. The item should not be tightly packed with linen to allow sufficient steam circulation, and the lid of the autoclave drum should not be left open because it may lead to contamination. There are 2 types of autoclaves. One is gravity displacement, in which the steam moves from top to bottom by gravity, and then is the pre-vacuum. Here the air is removed by vacuum pump. It is also known as dynamic air removal autoclave. The other option for high temperature sterilization is hot air oven. Ideally, it should be a stainless steel chamber with perforated shelving. Here the convection current is passed. Alternatively, a simple oven with a thermometer can also be used for dry heat sterilization. Metal sheets of cystoscopes and sharp instruments can be sterilized by hot air oven. And high temperature sterilization technique damages the optics of instruments, which is the older optics rod length system is damaged by the high temperature sterilization, and this can be prevented by using low temperature sterilization. Then comes low temperature sterilization. It includes, first one is hydrogen peroxide gas plasma sterilization, or as simple known as plasma sterilization. Here 1.8 ml of 58% hydrogen peroxide is vaporized in a sterilized chamber. Then the vapors are converted to plasma using radio frequency energy. Plasma has highly charged particles and free radicals that sterilize the instruments. The advantage is that there are no toxic byproducts of the sterilization, and the cycle time is also short from 35 to 60 minutes. Most of the instruments can be sterilized and it is easy to operate. The disadvantages of plasma sterilization are it requires a special unit and plastic for packaging. The peel open pouches are required for packaging. Then corrosive sensitive metal cellulose cannot be sterilized by this method, and it is an expensive sterilization method. Then comes ethylene oxide sterilization. This process causes alkylation of proteins and DNA and RNA. It is a very useful method of sterilization of heat or moisture sensitive instruments such as optics, plastics, wires, and electrical items. Excuse me. It penetrates the packaging material and can be used on industrial basis. After packing any of the industrial large volume products can be sterilized using ethylene oxide sterilizers. It requires a period of post-sterilization aeration to remove toxic residues. The disadvantage is that the residues are toxic, carcinogenic, and flammable, and it is a lengthy process of lasting from 12 hours or more. Then the ethylene oxide also has a risk for health personnel. Like if acute exposure can lead to irritation of eyes and the skin, chronic can lead to hematological changes, increased temperature of spontaneous abortion, and carcinogenesis. This is an image showing an ethylene oxide sterilized. Then comes gamma irradiation, third point of the low temperature sterilization. It is also used for various disposable product sterilization. Here, a radioisotope cobalt-60 releases high energy photons that ionizes the irradiated material that leads to damage of DNA of the organism, leading to its death or inability to reproduce. There is no residual radioactivity. Disadvantages: certain materials may be incompatible with gamma irradiation. Then comes the chemical agents, which is also one of the method of low temperature sterilization. According to the concentration and immersion time, the chemical agent can be classified as a liquid chemical sterilizing agent or a simple disinfectant. There are different agents according to the group available for in the chemical agents. It can be an alcohol, which is ethyl alcohol, isopropyl alcohol, which are used in concentration of 60 to 90% in water. Then comes the aldehyde group, which is glutaraldehyde, most commonly used, formaldehyde or orthophthaldehyde, peracetic acid, or iodophores. First is alcohol groups. It causes denaturation of proteins in the microorganism, leading to its death. The advantages are it is easily available, no activation time is required. It is used to clean the external surface of instruments like sonographic probes, and it is rapidly bactericidal rather than bacteriostatic. It is tuberocidal, fungicidal, and virucidal. Disadvantages are it is not sporocidal, and it can damage the mounting of lens or may harden the rubber and plastic. The cidal activity falls sharply when the concentration is below 50% in the solution. So optimum concentration, as mentioned before, is 60 to 90% in water. Alcohols are not recommended for sterilizing medical and surgical instruments because they are not sporocidal, and they are highly flammable and must be stored in a cool or ventilated area. They evaporate rapidly, so that is why the extended exposure time is difficult, which is required for a disinfectant to be classified as chemical sterilant. Then comes the aldehyde group. These cause alkylation of sulfhydryl, hydroxyl, carboxyl groups of the microorganism, which alters the DNA, RNA, and protein synthesis. They are relatively inexpensive, and most instruments can be disinfected using these aldehydes. Most commonly used in urology are glutaraldehyde 2.4% and orthophthaldehyde. Glutaraldehyde 2.4%, which comes by brand name of Sidexal-Glutaral. The disadvantage first is that it fixes the blood stains over the instruments if the instrument is not pre-cleaned before soaking in the chemical agent. Aqueous solution of glutaraldehyde which is available are acidic, that is not sporocidal. So the glutaraldehyde has to be activated or made alkaline by use of alkalining agents, most commonly being used is sodium bicarbonate, which brings the pH of the glutaraldehyde to 7.5 to 8.5. At this pH, it is sporocidal. But once the glutaraldehyde is activated, the shelf life is only 14 days, because once activated, it leads to polymerization of glutaraldehyde molecules at alkaline pH. So the SIDEC solution is only active for 14 days. That is why it is regularly changed after every 2 weeks. The advantages are it is non-corrosive to metals, does not damage the lens, instruments, or rubber or plastics like alcohol. All instruments should be completely submerged in solution. And for complete sterilization, it requires soaking from 10 to 12 hours. Sorry. After soaking instruments, disadvantages that the instrument should be cleaned with sterile water, or it can, if not cleaned, the glutaraldehyde can cause skin and mucosal irritation in the patient, leading to urethritis or colitis. And it is relatively slow microbactericidal, and less time of soakage only achieves the disinfection, which is ideally optimum for the endogeological instruments as they are semi-critical items. This is a SIDEX chamber in which it shows the completely submerged instruments. Then is the orthophthaldehyde, comes by the brand name of OPA. The mechanism of action is it interacts with amino acids, proteins, and microorganisms. The advantages over glutaraldehyde are that it's fast acting, it is non-irritant to eyes and nasal passage of health personnel, it does not require the exposure monitoring, and it has barely perceptible odor. It is stable over wide range of pH from 3 to 9 and does not require activation like glutaraldehyde. And unlike glutaraldehyde, does not coagulate or fixes the blood to the surface of spores. So these are all the benefits of orthophthaldehyde over glutaraldehyde. The disadvantage is it is more expensive than glutaraldehyde. It stains the skin and mucosa because it stains the proteins with gray. That is why it can lead to staining of skin and mucosa in patient. And sometimes it causes hypersensitivity or eye irritation in few patients. Then comes formaldehyde, or the last of the aldehyde group. It is used as a 37% concentration, which comes by name of formalin. It is bactericidal, tuberocidal, and fungicidal, and even sporocidal. But because of its potential carcinogen effect, which it causes lung and nasal cancer, it is not being used as germicide. Occupational state health agencies of USA have set an employee exposure standard of 8-hour time to maximum concentration of 0.75 ppm because of its potential carcinogen effect. Chronic exposures to formalin can lead to ear or skin diseases like asthma or dermatitis, and it has very irritating fumes and pungent odor. So it is being used very less these days. Then comes peracetic acid, which comes by brand name of PEROXIDE and Ecurox. It is an oxidizing agent, and it basically causes denaturation of proteins, disrupts the cell walls, and oxidizes the sulfidyl group. These are used in automated machines where the sterilization cycle is very fast, of 30 to 45 minutes, and done at a low temperature. The advantage is it lacks harmful decomposition products like acetic acid or hydrogen peroxide, and it enhances removal of all the organic materials, and it leaves no residue. And it is effective in presence of even organic matters like blood and tissue. It is sporocidal even at low temperature. Disadvantage again is it causes eye and skin damage with contact. And few manufacturers do not endorse this sterilizing agent due to potential material incompatibility. Then comes iodophores, which includes the iodine solution or tinctures. If the iodine solution has a detergent in it, then it is called betadine scrub. And if it has no added detergent, it is called as betadine solution. Combination of iodine and solubilizing agent or a carrier is used in this iodophores. It causes sustained release of free iodine in solution, which causes disruption of protein, nucleic acid structure, and synthesis. FDA has not cleared any of the liquid chemical sterilant with iodophores as main active ingredient, and it is only used for high-level disinfection of endoscopes, but it does not cause any stains and is economical and widely available. It has a adverse effect on silicon-based tubings. Then comes hydrogen peroxide. The mechanism of action is hydroxyl-free radicals which are released that leads to attack of membrane lipids, DNA, and session cell components. The catalase enzyme present in aerobic organisms or facultative anaerobes protects the organism from the hydroxyl-free ions. This defense is overwhelmed by increasing the concentration of hydrogen peroxide to disinfectant levels, which are mostly 3 to 6%. Then they are stable and effective disinfectants, and it has no odor. The disadvantage is it is chemical irritant, can cause pseudomembranous colitis. Regular monitoring of dilution is also required, like in Cidex or Glutaral. This is an image here. It's large number of points have been mentioned, but basically it compares all the different chemical agents available. We'll concentrate only on the important points. First is no parasitic acid. Here advantages, though no activation is required. The disadvantages, there are incompatible materials like lead, brass, and and it can also cause eye and skin damage. Then comes glutaraldehyde, which is most commonly used by concentration of 2.4%. It is inexpensive and excellent material compatibility is there. That is why it is used most commonly. But it can also cause respiratory irritations and asthma-like condition on chronic exposure. It has a pungent odor, slow microbactericidal action, and allergic dermatitis. And concentration monitoring is required regular. Then comes hydrogen peroxide. Here, no activation is required, and no disposal issues are there, and it doesn't have any odor. But again, the instruments or material incompatible are brass, zinc, and copper, and it can cause serious eye damage. In orthophthaldehyde, it is a fast-acting, no activation like glutaraldehyde is required, no odor, and excellent material compatibility is there. But it again stains skin and mucosa gray. Repeated exposure hypersensitivity can be there. It is very expensive and very slow sporocidal activity. Last is parasitic acid. It has a rapid cycle time if used in an automated machine, like 30 to 45-minute cycle are there. It can be used at low temperature liquid immersion. There are no adverse health effects to the operator, and it is rapidly sporocidal. Again, the disadvantages are that it is a biological indicator, may not be suitable for parasitic acids, and it is very expensive, and it can cause serious eye and skin damage. Last is the video of cleaning of endoscope, cleaning process of the endoscope. It's a long video. We'll concentrate only on the main points of the video. I'll start with the video. First comes the pre-cleaning. In pre-cleaning, we usually remove all the visible organic or inorganic tissue present on the endoscope by using a wet cloth which has been immersed in a detergent solution. Then comes the most important point of leak testing. Here first we remove all the biopsy caps and flushing adapters, and then we attach the leak tester or pressure instrument to the venting connector. Then we immerse the initially before immersing, we connect the pressure gauge to the connector through the leak tester instrument. If the pressure gauge shows the fall of the pressure after attaching to the pressurizing instrument, that means there is definite leak. That instrument should not be even immersed in the endoscope, or it may lead to the damage of the endoscope. Then after, if the pressure is not falling, then we can immerse the solution, immerse the endoscope into the solution. After connecting, then here the pressure gauge has been attached first.
Yes, Sahasdeep, we have already seen it. Just a little forward.
Yes, sir. Then we look for the important point is, if it is a flexible endoscope, all the parts should be moved to check for the leaks from for the air bubbles from all parts. Then next important point is brushing. Brushing of all the channels. This is a very important point. The brushing is done with the long brushes which are available with
Sahaj,
every instrument.
just a small question. You are showing about the leak testing.
Yes, sir.
Is leak testing really relevant to your disinfection or sterilization, or it has got more to do with the integrity or the damage of the flexible endoscope?
Yes, sir. Sir, it is basically being done for flexible endoscopes. The basic issue here is to prevent the damage of the endoscope by the disinfectant, sir. That is why it is being discussed over here, sir, so that if while during any disinfection procedure, the endoscope, flexible endoscope has to be tested before immersion of the endoscope into the chemical sterilant.
Yes, yes.
That is why
Right.
it is being used, sir. And
Continue.
the second point is that, sir, if there is by chance leak in the internal channel, and then the disinfectant can lodge over there, and after removal, after that, if the same endoscope is used in any patient, it can lead to the disinfectant caused injury in the patient. That is why, sir, these 2 points emphasize the use of leak testing in or any of the flexible endoscopes before any.
No, but the injury to the endoscope can be caused not only on account of disinfection, it can also be caused on account of the use of the endoscope. While doing a surgery, sometimes if you bend the endoscope too much,
Yes,
there can be a rupture of the sleeve or
Yes.
the insulated
Yes.
coating around the endoscope, and that
Yes,
can
sir.
lead to a positive leak test. So
Yes,
it
sir.
is not only on account of the disinfection injury, on account of the actual use of the endoscope also. That was the point I was trying to make.
Right, sir. Thank
Okay,
you.
okay. Let's
Yes, sir.
complete your video first. Complete your video.
Yes, sir. Then these are the 2 important points, sir. Brushing of all channels, and then it comes water rinse. Just a minute. After immersion into the liquid, sir, they have all the endoscopes have to be water rinse to remove all the disinfectant retained inside the endoscope, so that it does. All the channels should be flushed properly. First, internal channels are flushed. Then we remove wash the external surface, and then is the last procedure of disinfection and sterilization, which is according to the manufacturer instructions. That's it, sir. Thank you, sir. Hello.
Thank you, SAHADEEP. Unshare your presentation.
Yes,
and I would request anybody, if he has a question, please go ahead. We have nursing staff also with us probably. Do we have a nursing staff with us in this presentation, in this session? Let me see. Okay, any of the residents or faculty, any question?
Sahaj, Sahab Singh, what is the difference between the high level, intermediate level, and low level sterilization?
Sir, high level, intermediate, and low level are according to the.
Just hold on. SAHADEEP. Sahab, did you listen to the presentation?
Yes, sir.
Are you examining him? He has already told it in the presentation. What are you going to if you have a query or if you have a doubt, ask him.
Yes.
Are you his examiner?
Good morning,
If
sir.
you have a doubt, let me know.
Yes.
Tell me what are the different processes of the whole sterilization process, Sahab?
Yes, sir.
How do you sterilize the instruments? Your cystoscope, telescope. How do you start the whole process?
Sir, there are different methods. One forms are in sort of methods like immersed into the formaldehyde.
Oh, you have not studied the, you haven't listened to the presentation at all. How do you start the whole process? You start by immersing into solution, Sidex. What do you do?
First by
Once you have used the instrument.
so first by cleaning,
Then? So you haven't even seen the first slide of Dr. SAHADEEP. Anybody else has anything to say?
Sir, I have a question, sir.
Bolo Neeraj. Go ahead.
Yes,
Sir, I think in the presentation said that endoscope ideally should not be autoclaved. Am I right, sir?
sir, old endoscopes which were using the rod lens system, they should not be autoclave because, sir, there is unequal expansion of the glass and the rod, which can lead to damage of the optics, sir. The newer systems, newer endoscopes which are using the digital cameras and they don't use the rod lens system in optics, they can be autoclaved, sir. But that also according to the manufacturer instructions, sir.
Right.
No,
So
but
now most of the instruments are autoclavable.
Autoclavable, and it's even written on the
we used to have,
endoscope.
Now, previously we had instruments which were not, could not be autoclaved. Yes. But I think, Sahaj, you took a video from gastroenterology people.
Yes,
Didn't you find something to deal with urology instruments, the cystoscope, telescopes, which we use so often?
Yes, sir. Yes, sir. The
Yeah.
rigid endoscope videos were also available, sir, but they were only showing the dismantling and the cleaning procedure available, sir. But this video had the leak testing and brushing of all channels procedure who was fully elucidated, sir. That is why
I think let us prepare a video on how to. So you are given this task of making a small video on
Yes, sir.
how to sterilize our instruments, the
Yes,
resectoscope, telescope, etc.
Yes,
From the beginning, how to clean them, how
Yes,
to dry them, how to
Yes,
clean their channels, and
Yes,
then how to put them either autoclave or plasma, whatever it is. So make a small video for
Right.
our urology instruments. You
Yes.
can take help from some of the faculty and residents.
Yes, sir.
And I want you to make this a small video.
Right, sir. Sure, sir.
And anybody else has any question, query, doubt?
Sir, a comment tha, sir, mera, sir.
Yes, Neeraj,
I
go ahead.
remember when I was a resident, sir, many years back, we used to dismantle the endoscopes ourselves, sir. All the resectoscope sheath, outer sheath, inner sheath, working element, and we used to wash them, sir, ourselves. The residents used to wash those instruments, and then they used to immerse it in the Sidex or any other solution. Nowadays, what has been happening is that most of the instruments are being handled by the nursing staff only, sir. So probably the residents are not getting that much of an exposure in assembling, disassembling, and the proper washing of the instrument. So can we formulate some sort of a policy which residents should actively, take up the role of washing the instruments also for the teaching purpose, basically, and they will get to know once they do it practically. Ye was mera suggestion tha.
No, it's a very good suggestion. I think that's why
Because I have hardly seen any resident or any other faculty washing the instruments themselves, sir. It should not be looked down upon. Matlab, ye ek bahut imperative part hai once they go into practice and move out. And this is a thing which they'll have to do it themselves only. So ye ek suggestion.
Right. I think yes, definitely, it's a very good suggestion. We would try to implement this so that every resident at least knows how to dismantle and again arrange the instruments, how to clean them also. So I think we will implement this. There is a question from Dr. Sunil Mittal. He is saying, please share how many of us are using ETO for flexible scopes. I think nobody has answered this. We in our department definitely do not use ETO. We are using either autoclave or plasma. So most of these, many of these flexible instruments, our laparoscopic instruments, all these are being plasma sterilized. And otherwise, routinely, we send the instruments for autoclaving. And please share the biological monitors used for ETO and how and where to get them. So again, that's a question. That's a question which probably we may not be able to say because we are not using ETO. Does plasma score over ETO for sterilization? Yes, I think so, because plasma is the latest thing and probably it scores. Dr. Sahaj, would you like to comment on this?
Yes,
whether
sir.
plasma is better than ETO?
Yes, sir. So basically, the difference come over is that the residues of ethylene oxide or the effects of ethylene oxide are toxic to the health personnel, sir. Like in acute exposure, it can cause skin and eye damages, and chronic exposure to ethylene oxide can lead to hematological changes and risk of spontaneous abortion and even carcinogenesis. Whereas in plasma, there are no toxic residues, so it is better as over the health effects to the health personnel using the method of sterilization. Sir.
And I think this is faster also. ETO takes a slightly longer time. Probably.
Yes, sir.
Yeah,
yes,
and ETO has a kind of a big kind of a instrument, and a plasma could be just a kind of a small fridge-like thing, which can be even put in our operation theater, and we can utilize it. So, anything else? Anybody has it? And then. Any faculty has any query? Otherwise, we'll just wrap up the session. Dr. Ajay, kindly give a thanks of word, and then we will wrap up it.
Sir, Sahaj needs to be complimented, sir. It was a very good presentation. He spoke very well.
Thank you,
and
sir.
all the things I think he covered very nicely, sir. So
thank you,
yeah,
it was a good presentation.
Thank you, Neeraj. I also agree with you, Sahaj. You did well. And you answered the questions also well. So my compliments from the department, from the faculty, from behalf of the faculty. Thank you very much. So I want that other residents also get inspired from Sahaj and do well in the next presentations. Ajay, go ahead with the last comment and thanks. So if Ajay is not there, I will just thank all the faculty. Yes, Ajay, go ahead.
Yes,
Ajay, go ahead.
Thanks a lot, Dr. SAHADEEP, for an informative presentation. And thanks a lot, Swam sir, for enlightening us with your valuable suggestion on this topic. Thanks. Good day.
Thank you. Thank you, everybody, and have a good day. Thank you.
Thank you, sir.
Ananya?